Hi everybody. All right, so today I'm really excited to be teaching you this lesson. It's one of my favorites. Today we're going to be talking about ratios and proportions. We are in section 3.9, and again, I'd like you to go ahead and put the date on the top. And I know that a lot of you have seen ratios and proportions a lot, but we're going to be making them harder now. And we're going to use them in real life examples. Proportions and ratios can really just help us answer so many different types of problems in geometry, in pre-calculus, in algebra 2, and in real life. So I really like teaching ratios and proportions. But first we have to define what a ratio is. A ratio is just a comparison, and you guys have your note sheets, so a comparison of two or more quantities, so two quantities, okay? Yes, and some ratios can actually compare more than two quantities, but for now we're going to compare two quantities. It can be expressed as a fraction, it often is. It's often expressed as a fraction, but it doesn't have to be. Okay, there's lots of ways. We could say if something's 34 in the ratio of 34 to 10, we could write it like that. We could also write that as 34 over 10. And we could write that as 34 dot 10, okay? So basically these mean all the same thing. Now you do have to be careful. If I say 34 to 10, you can't write the fraction with 10 on the top. The numerator always has to be the first one that comes in to the left of the 2, okay? All right, so that's a ratio. Now a proportion is slightly different. A proportion is actually two equal ratios. So a proportion might look something like 34 over 10 equals 17 over 5. Now that's a completed proportion. And the left side, if it's reduced, should look like the right, or the right side, if it's reduced, should look like the left, because they are equal. So we need to make sure that we understand that. We're using this concept of equal to help us solve different problems. Okay. Several ways to solve proportions. So let's look at, and I want to go back here 1 second. One thing I forgot is that sometimes proportions are written as part to part, and sometimes they're written as part to whole. And I'm going to discuss that when we get into word problems, because we have to be really careful about how we read our word problems, okay? Okay, so here's our first one, and I put two equal signs here. Find the missing number, okay? So we have 15 over 40, and we have x over 8. So one way to solve a proportion is to really think about that they are equal, and that's why I put the equals twice. I know that 8 times 5 is 40, okay? So 40 divided by 5 equals 8. So you could actually do the exact same thing to the top number. So 15 divided by 5, and that would give me 3. So one way to find a proportion is either to multiply or divide these numbers by the same number that's going to give you one of the terms on the right side. I don't really love that, because the ones that we're doing in algebra are going to then involve longer and binomials or longer variable sets and expressions, and it doesn't always work as easily. Okay? All right, so let's look at this one. 4 over x equals 12 over 24. Another way to solve a proportion is actually to multiply by the LCD, the lowest common denominator. But you got to remember, you've got a 24 and you have an x. So my LCD in this case would be 24x. So this is based on kind of what we just did with clearing fractions. So we multiply both sides of the equation by 24x. Some of you are going to feel comfortable doing it like this, okay, and that's fine. All right, so then the x's would cancel, 24's would cancel, so you'd be left with 12x equals 24 times 4, and again, you can do this on the side. So 24 times 4, 4 times 4 is 16, 4 times 2 is 8, plus 1 is 9, so 96. Okay, and then finish the problem. 12 times x. If I want to isolate x, I have to do the opposite operation. So I'm going to divide by both sides by 12. Okay? And x would be what? 12 goes into 96 8 times. Okay? So that's also one way of doing it. That's not right. That is right. Okay, just making sure I did that right. Sorry about that. Okay, so we keep going. That's one way. Another way to solve a proportion, and did I use the exact same one I did? Another way to solve a proportion is to cross multiply. Not cross cancel, but cross multiply. So cross multiply means multiply these numbers and multiply these numbers. And I put a little x in the middle so we know it's multiply. So I have 4 times x, which gives me 4x. I have 7 times 12, which gives me 84. Put an equal in the middle. Bring that equal down for me. And then do your opposite operations to solve for x. So we're going to divide both sides by 4. So then x would equal, 4 goes into 8 2 times, 4 goes into 4 1 time. So x would be 21. Okay? So you can use any of those examples. I'm perfectly acceptable with, I will accept any one of them. You're going to probably feel more comfortable with certain ones, okay? So let's look at some harder examples, okay? So let's look at some harder examples. So the first one is 2w over 16 equals 30 over 80. Okay, well the first thing that I would tell you to do is simplify, okay? But now, we have an equals here. This is not simplify then multiply. This is not multiplying fractions. These are proportions. So simplify, you can simplify up and down on the left and up and down on the right. Okay, and that's it. That's the only place you can simplify if you're dealing with proportion. So I looked at this and I was like, okay, I can cancel 2 into 6 8 times. And I'm going to rewrite that as w over 8. Okay? And then over here, the zeros cancel. So I have 3 over 8. So if you go through that simplification and we look back at the process number 1, 8 times what gives me 8? 8 times 1. So, and vice versa, if these are both the same, then what would w have to be? W would have to be 3, okay? So this is a nice, easy example, but it wouldn't have been as easy if you didn't simplify first. You'd be doing, if you cross multiplied, you'd be doing 80 times 2 and then 16 times 30. So you can see how difficult that would be. If you found the LCD is actually 80, so you're multiplying by this really large LCD that you might not have recognized. Okay, so let's keep going. All right, next harder example. X plus 5 over 3 equals 11 over 7, okay? All right, so again, 2 ways you could do it. I'm actually going to cross multiply in this one. I actually like to cross multiply when I have a binomial, an expression, a variable expression in any place on the fraction. So cross multiply means multiply diagonally and keep your equals, okay? So I have 7 times x plus 5, and I have 3 times 11, okay? So then I have to, what do I have to do? Distribute means, yes, distribute means multiply. So I have 7x plus 35 equals 33. And there's then one of those nice linear equations that you guys, we've been practicing that you're great at, okay? So I have to do backwards PEMDAS. So the first thing I'm going to do is I'm going to bring the 35 to the other side. I want to balance out, so I want this to go to 0, so it's got to be the opposite operation. So there we go. Those cancel to 0. So now I'm left with 7x equals -2, because I have 33 minus 35, different signs, subtract the numbers, and then keep the sign of the larger number. So -2. And then divide by 7. So x equals -2 over 7. Okay? All right. And you can always take your answer and plug it in and simplify this, and it should look like the right. Okay? Now I want you to try one. Here's a little bit of a harder example. That's not what I wanted. I wanted a new page. Let me go back. Okay. And let me grab my eraser for a second. And I'm going to erase. Isn't that cool? Woo. There we go. Okay. So here's the one I want you to try. 16 over 35 equals 2 all over c minus 8, okay? So it's got a variable expression, so you can decide which one you want to do, multiply by the LCD, use the multiplication process, or cross multiply, okay? So I want you to press pause, and I want you to try the problem. I'm waiting for you to press pause. Okay, and then I'm going to do it, so come back to us now. I'm going to cross multiply, so I have 16 times c minus 8 equals 35 times 2. Now remember, you bring the equals down. I always tend to put whatever number is up here on the left, and then we're going to distribute. Again, don't forget to distribute to everything, and distribute means multiply to everything within the parentheses. So I have 16c minus, I have 16 times 8, and guys, you have to be able to do this. 16 times 8, 8 times 6 is 48, carry the 4. 8 times 1 plus 4 is 12, isn't it? Yep, good. So minus 128 equals 35 times 2, hopefully you're seeing that, works out to be 70. Okay. All right, we keep going, right? We keep going. So we add 128 to both sides. And we get 16c. These cancel to 0. And we get 198. Okay. Now these numbers are bigger, but that doesn't mean that you can't do this without a calculator. You can do this, okay? So we need to divide 16 on both sides. We have to also remind ourselves over and over that that division bar, that fraction bar means division. So divide, guys. Go to your paper. Do 16 into 198. 16 goes into 19 once. Put the 16. Subtract. 19 minus 16 is 3. 16 into 38. 16 goes into 38. Let's see. 2 times. 16 times 2 is 32. Bring the 6 down, okay, and then write it as a fraction. 12 and 6 over 16. Reduce. 2 goes into both of them. 2 goes into 6 3 times. 2 goes into 6 8 times. So my answer, 12 and 3/8. Okay? Perfect. Now let's move on. We're going to look at some word problems. How can we do this? Oh, so let's just review the method. Sorry. A proportion can be solved using different methods, right? We can make equal fractions by just looking at the fractions and seeing what number was multiplied to get to the consistent number on the right or the left side. We could do that. Not the best, not my favorite. We can multiply both sides by the LCD. Okay, so multiply by the LCD, or we can cross multiply. And again, whichever one you feel the most comfortable with, okay? All right, so let's look at some now examples. The school was holding a food drive. The ratio of cans to boxes was 3 to 4. If Austin counted 120 cans, how many boxes should he have? Okay, so you are going to use the concept of proportions to write yourself an equation to solve for x. All right, so the ratio was 3 to 4. So I would go ahead and write that as a fraction, 3 over 4. But make sure you understand what number belongs in the numerator and the denominator. I know that it was cans to boxes. So the 3 is my cans, and the 4 was my boxes. Because when you write the proportion or the ratio on the right, it has to be in the same location. So I know I'm writing a fraction. He had 120 cans. Cans was in my numerator, so that 120 goes there. How many boxes should he have? So we're trying to find the boxes, so that's my x, okay? Either way, multiply by your LCD or cross multiply. In this case, I see the LCD is nice and easy. It's 4x, so I'm gonna multiply both sides by 4x, okay? That will cancel with that, and the 4's will cancel here, so we'll get 3x equals 480, okay? And then what do we do from there? We divide by 3 on both sides. That will clear the x to and then will be 480 divided by 3, which gives me 160. So we have 160, and we would answer it using boxes. So this is how do you use proportions. This is how. You take your ratios, you set it equal, you put in a variable for the missing information, and then you solve just how you know how with a proportion. All right, let's try a couple. Roy's yard is covered with walnuts. He will pay $2.50 for every 3 buckets of walnuts you pick and put it in the trash. How much will you make if you pick up 12 buckets of walnuts? So we have to think about this. We have $2.50 for every 3. So I'm going to say $2.50 to 3. Make sure you realize the dollars is in the top and the buckets are in the bottom. And it says how much will you make? What am I asking for? What do I want to find? I want to find money. Money was in the top. What was I given? I was given 12 buckets. Okay? So now this one might be a good place for you to recognize 3 times what gives me 12. Use that easier concept. 3 times, hopefully you're saying 4. Okay, so times 4. So to get your x, you can just multiply the top by 4. Because they're equal proportions, we multiply and divide by the same number to get equal on both sides, okay? So then I have $2.50 times 4, which is $10. Good. So x equals $10. Okay? All right. Let's look at the next one. Keep going. The Saturday afternoon movie has a special deal. For every 2 adults purchased, 3 children get in free. If 13 children are attending your birthday party, how many adults must be bought? Okay, so I did 2 to 3. I reminded myself that it was adults to children, so that I know that when I write my proportion, I'm correct. So there's 15 children attending. That has to go in the denominator. I want to know how many adults, so that's where my variable is going to go, in the x, in the numerator, okay? Okay, multiply both sides. I'm going to try by the LCD here. The LCD is 15. I'm going to multiply both sides by 15. Okay, these are going to cancel. Ooh, I get x by itself. It's so nice. 3 goes into 15 5 times. Cancels to 1 there. 5 times 2 gives me 10. So how many adults are attending? 10 adults. And there we go. I haven't been doing a good job of boxing my answers like I'm always telling you to do. Okay? All right, so let's look at the next one. I want everyone to read the next one. While making necklaces in your art class, you select a pattern of pink and green beads. There are 4 pinks for every 5 green beads. How many of each color will you need if your entire necklace has 45 beads on it? So now we've got our entire necklace has 45 beads, so we have to be really, really careful here. So it's not the same ratio. This is one of those ratios where I said was part to whole. Okay? We were given part to part, but we were given the second part of our ratio was given as a whole. So we have to consider that. So normally it's 4 to 5. But couldn't we say that pink to whole was 4 to 9? So this was the pink to the whole. Okay? So I'm going to take that 4 ninths, and you could have also done 5 ninths, it wouldn't matter. And actually I am going to switch to 5 ninths because it's an easier number to go with 45. So green. So I'm going to do green. So 5 green to 9. Whole, total beads. And I'm going to set it equal to what I have. So remember, this was the green and this was the total. So we're going to set it equal to x over 45. There's my total. Okay, I'm going to multiply both sides by the LCD, which is 45. Okay, and the 45s will cancel. Nice clean x on this side. 9 goes into 45 5 times. 5 times 5 is 25. So that means there's 25 green beads. And how can we find the pink beads? Well, if there were 45 in total, we do 45 minus 25, and that's going to give me 20. Okay? All right, so on your worksheet there are there's about, I don't know, like 6 more that I'd like you to try and be prepared to go over. So just finish up the worksheet, bring it to class, and we'll see how you did. Okay? Thanks, and have a great day.